to Daniel Yeh from the University of Florida. Daniel is our second speaker. He will tell us about a compact water recycling and an energy harvesting system for off-grid public toilets in low-income urban areas. Daniel, the floor is yours.
Okay, very good. Hi, hello everybody. It's a pleasure to be here, and greetings from Tampa, Florida. So today I'm going to describe our technology, which is called the NEWgenerator, and NEW stands for Nutrients, Energy, and Water. We have a great team of graduate students and undergraduate students at USF who work on this project over the past few years. Some background on the technology. It is meant for really wet material, meaning either wet wastewater or wet sludge pits. So contrast a little bit with what Brian's going to be presenting on mostly dry material. Because the system is based on membranes, it has some nice scalability associated with it, meaning if you want to increase the capacity, you can just do so by increasing the membrane areas available. In a nutshell, basically the technology utilizes anaerobic processes to convert a waste organic matter to biogas, and then a membrane is utilized for to polish the effluent as well as to retain the biomass, which is a very important consideration for this process. Okay, just to make sure that everybody is familiar with what the membrane bioreactor is, it's basically a way to combine a biological process with membrane filtration. You know, the first patent actually came out in 1967, but it wasn't until I think the early 90s when this started to gain commercial traction. And now the membrane bioreactor is quite popular commercially, at least for aerobic systems. So one important thing that MBR is able to, I think, improve upon existing wastewater treatment technologies is that the filtration of the effluent or the retention of biomass using the membrane allows colloidal material to be separated. And this is something that gravity-driven processes cannot. So it reduces the pathogen loading into the effluent, and also reduces the size of the system. So we can have very compact systems made available. Here's a chart showing the rejection coming from different sizes of membranes. And usually for membrane bioreactors, we're looking at either microfiltration or ultrafiltration, as shown on the top of the diagram there. So for those two, we're looking at rejection of bacteria and viruses, colloidal material, and lots of macromolecules in the system. Just about all of the pathogens of interest typically we encounter can be rejected by the membrane. So for example, we have 0.03 microns or 30 nanometers as the typical pore size, and that is considerably smaller than the pathogens of interest. So there's been some creative uses of membrane bioreactors. For example, they've been used in green buildings, on cruise ships, and for sewer mining. So a number of very compact operations have been utilized around the world. So what we're interested in is that we have this very nice technology, but can we apply this to the developing world? And this article in the Water Environment Technology came out about 10 years ago to basically challenge that concept. Can this MBR be made for the developing world? And if so, what are the hurdles? So here in this slide, this group of experts, water experts that gather in Bellagio, Italy, they analyzed the MBR technology and said, well, there are a number of nice attributes, such as a very compact system and high-quality effluent, remote operation. However, cost, chemical usage, energy, membrane fouling, those are all issues that need to be overcome. So that has sort of laid out some of the motivation for our lab over the past few years to try to address those issues. So one of the first things that we decided to do is that existing membrane bioreactor systems are aerobic, and we cannot continue on that path for namely energy and sludge generation considerations. So we have to go anaerobic to achieve a net positive energy system, meaning okay, so and then one of the things about anaerobic processes is that it generally does not remove nutrients. However, this can be turned into advantage if we're looking at nutrient recovery. So, which is the direction that we're going in. You know, treat the nutrients as an advantage that you'll gain from the system. In fact, the membrane will basically filter out the organic material and make the nutrients almost immediately available for reuse. And I'll discuss that very quickly. So we've gone through different stages of the technology development in our lab. Here's a picture of the TRL5 system that we had in our laboratory, and this is based on a synthetic wastewater treated. You see on the right side of the picture, that diagram basically shows the membrane system being used. It's a tubular membrane, 0.03 microns, and the wastewater enters through the middle of the membrane and gets filtered out. And you can see the outside of the membrane is very clear. It basically generates a very low turbidity water and low solids water that can be used for reuse. So from that, so here's a picture showing what goes into the system, the vial on the left, and the permeate is generated on the right. Here are some attributes about what the system was able to do. If you're interested in reading more about that, we have a paper in the Journal of Membrane Science which describes that particular system, the TRL5 system. So after that, we received funding from the foundation, and we move on to a TRL6 system, which is basically, now we're looking at relevant environment, treating actual wastewater. And here we were able to combine funding from a few other sources with the National Science Foundation to really look at the whole concept of waste to resource recovery. So some of the things we wanted to demonstrate with the anaerobic MBR in the field version was how will it perform with actual wastewater, what are the challenges under sort of extreme heat conditions that we experience in Florida, and also you know, what can we use the effluent for? So we demonstrated the use for direct irrigation or fertigation to grow crops via hydroponics, look at struvite recovery, and also microalgae production from this. So our concept for the NEWgenerator is really, you know, you can't just look at waste as a waste problem. You have to look at the entire cycle. So we're hoping that through the NEWgenerator, you know, we're able to obviously contribute to solving a waste problem, but also the resources that are recovered can be used to solving other problems. For example, the biogas could be used to solving some of the indoor air quality problems faced from using dirty fuel to cook. The nutrients and water harvested can be used for agriculture, so we can complete the cycle.
Daniel, thank you. Is that your last slide?
I have two more. Okay. So in terms of going forward, we just in addition to the GC funding, we just received additional funding to go to India through the Reinvent the Toilet Challenge in India. So we'll be doing that, and then also we're currently in a competition for the Ekane Museum, looking at basically innovation. So this is where we're going to be India later on this year. We're teaming up with Scientific, which is, as many of you may know, they are a developer of an innovative toilet product. But the issue that faces is that the wastewater is currently treated and discharged into the ground and not able to be recycled. So we're hoping that using the NEWgen technology, we can recycle the water and combine it with an e-toilet, we can create a closed loop system, and that the entire system can go off-grid, be operated just off the waste. And this will solve a lot of the water scarcity issues that India and other places face in terms of sanitation provisions. Because in many communities, you know, use of water is still culturally preferable, and you need a way to recycle the water.
Thank you very much, Daniel. I have to cut you there.
No, I'm done,
Sorry.
So go ahead.
Yeah, sorry, I just have to cut you there so we can move ahead to questions. So we have 5 minutes for questions, and the chat window is open for those that want to drop chats. So please, any questions to Daniel following his presentation?
Question from Brian.
Okay.
Yep, Brian, go ahead.
Yes, I was wondering if these membranes have to be cleaned or replaced on some time scale. Do they get clogged, or is there some mechanism?
Yeah, hi Brian. So, all membranes foul. I mean, that's just a fact of life, just like all clothes would get dirty, right? So the issue is how do you manage it and how do you control that? And this is why in most of the literature, membranes and membrane bioreactors are related to fouling control. So what we're basically doing is anticipate the amount of fouling that would happen and basically designing our system to deal with that. The idea is that we will not have to clean the system for several months. In fact, for our laboratory and field systems, we don't have to clean them for maybe 4 to 6 months. And then if you do have to clean it, it needs to be done in a very simple way so that the average person just taking care of the toilet can do that as well. And in terms of replacement, we're looking at least a 5-year cycle on that. And one of the things also with membranes is the cost has really come down considerably in the last decade. So this is almost becoming a commodity now, and it's available in many places, including India.
Yeah, thank you, Daniel. Does Dorothy also has a question? Dorothy?
So I didn't. There is one from Marcus in the chat. What is the typical COD you get in the permit?
Okay. So the typical COD really depends on the strength of the wastewater, right? Because it's a rejection, so it varies a little bit if you have higher strength wastewater. But for typical wastewater that we're looking at, we get greater than 98% rejection of the COD. So what's in the final COD is less than 20 milligrams per liter. In many cases, less than 10 milligrams per liter. And but the numbers that we're getting are all within the WHO water reuse guidelines.
Yeah, thank you, Daniel. I saw in one of your slides there that you will be collaborating with Aram Scientific Solutions in India. We've had them on the webinar here in the past. So what kind of collaboration will you have with them? How will you operate together?
Okay, as I explained in the previous slide, so basically, Aram has these toilets and they're looking for partners to recycle the water. And so what we're planning on doing is we're starting out with one demo site, and we do have some proposals that are being considered for additional sites. But we want to demonstrate that we can take the entire toilet off the grid, so that the wastewater generated by the toilet will be completely recycled and be put back in the toilet for use. And what we have to make sure that is that water is safe for human contact, is appropriate for that use. And also the energy will be entirely generated by a NEWgenerator to run the e-toilet. So there's simultaneous design issues on both sides, on the e-toilet and the NEWgenerator, to make sure that at the end we have as low an energy footprint as possible.
Thank you, Daniel. Thank you very much, Daniel. Great,
Very good.
great presentation, great project. We will dive in straight to the last presenters.